Let's go. I really got the feeling today that everything is going my way. Now this is what I'm talking about. Every time I see your smile, it makes me shout. Let's go! Let's go! Nothing's gonna stop us today. Get on the bus or get out the way. We're cruising with the radio on. So turn it up to 10. Here comes our favorite song. Let's go! Let's go! Let's go! Let's go!
Be right back. Hello. Hello. Yes. I think the sound is back. If you can hear me, just give me a thumbs up or let me know if you can hear me. Dara, thank you very much for calling that out. Someone is awesome. Someone is watching me from Periscope. Forgive me. It's that's 8 element. I think it's 8 element, right? 8 element. Awesome. Thank you. Thank you. Thank you. 8 element. Awesome. Awesome. Well, guys, in the spirit of Christmas, I know this is not a Christmas light, but it's a light. I mean, it's a siren, but it's a light. Yeah, this is set the tone for today's episode. Thank you, guys. Welcome to another episode of IoT Tuesday. In today's episode, we're going to be doing something cool. We're going to be connecting some of the Groove Shield sensor kit to our Azure Sphere. This is what it's going to look like. I've already connected a few things here, but I'm going to go over it and show you how to connect it, build an application, just do the light. The end goal, what I'm trying to achieve is that I want this relay, the relay right here. Let me bring it in. Let me bring it so you can see this. Yeah, I want this relay to control our light right here. So I want a situation whereby I can connect the Azure Sphere to IoT Central using cloud to device and actually trigger this light through the relay to come on. And then further add some logic apps and some functions in there, do some sentiment analysis that can be turned on or off based on tweets that coming. So if you stay right with me, we're going to take the very first step. That is how to connect the Groove Shield sensor kit to our board. I will be right back. Awesome. We're back. We're back. We're back. So let's get right into it. A few things I want to bring to your attention. That is, there has been some, how do you call it, some improvement or some enhancement to the Azure IoT Edge automatic deployment. Now, if you're not familiar with IoT Edge, I would entreat you to go check it out. I'll put some, some resources in the show notes so you can take a look at that. Now, basically, this allows you to run IoT specific stuff on your edge. So in cases where you have network connectivity, you can have a mesh of devices, and all the central kind of like knowledge or brain work will be done on the IoT edge, where you have the 10 edges or smaller clients connect to it. Also check out IoT Edge and IoT Hub. There's some new improvements also happening in that space. So today, as mentioned, let me take you back to the workbench. We're going to connect Azure Sphere with the Groove Shield that came with it, and then today's focus is going to be on the relay. All right, I'm going to show you how to do that. Hi, welcome Christian Valentine Chigbe. Thank you for joining the stream. You're welcome to the show. So a few things. I mentioned that the Azure Sphere is one of the secured MCUs that Microsoft has collaborated with some manufacturers to build. If you want to know more about it, you can check out my previous videos where I talk about how to set it up and all that. So in today's episode, we're going to be using Visual Studio to actually program our Azure Sphere. Um, During the course of this, if you have any specific questions for me, or there's something you don't understand or you need clarification on, please feel free to let me know. I will do my best to pause and answer. So let's take a look at what the Groove Shield is. Now, the Groove sensor kit or shield is a bunch of pre-made sensors that have been already connected to make your IoT journey very easy. Let me show you something right here real quick. Now, gone were the days if you were working on IoT projects, all right? You needed to have, where did I throw that? Anyways, now gone were the days. Let's switch to the bench so I can show this properly. So now gone were the days when you're working on IoT projects, you needed a breadboard, all right? And this is how a breadboard looks like. So with a breadboard, you had to connect all your sensors directly here, and then you need jumper wires to connect from this breadboard to your MCU or your microcontroller unit. However, what Groove did was that they came up with Groove Shield for multiple microcontroller units that you could just put on them. Sometimes it's referred to as a hat. So you will put this on your various microcontroller units, and they make this easy clickable cables. All you need to do, like in the case here, all I need to do now is just connect it and then put it on the shield. That's it. That's just about it, right? You don't need to stress yourself with jumper wires, breadboard. So this, we don't need it. Throw it somewhere else. So that is what the Groove Shield kit does. They have different sensors or different kits for different MCUs. In fact, let's actually let me bring this here. So let's check them out. Let's see, Groove Shield for Azure Sphere. So there you go. Open this up. Let me make this a bit bigger for you to see. So there you can see this is the shield which you're seeing on my workbench, and these are a few sensors that you can buy that work with a shield. So depending on what you do, relays, if you want a temperature humidity sensor, whatever you want, you can connect, you can buy that and connect. It makes it a lot easier. So for prototyping and development, and it can tell you the various parts. It has UMART, it has a GPIO pin. So the only thing is that if you want to do production, how can we get the Groove kit and how much does it cost? Well, so as you can see right now, it's $15.19 for the shield, and you can have the various sensors. You can buy the sensors for like $9 depending on the type you want. But there is actually a kit that comes with some of the sensors. So if you get the kit, you should check out Seed Studio. They have a lot of that. Now, The good news is that I mentioned that Azure Sphere comes in two flavors. The official ones comes in two flavors. The first one was done in conjunction with Seed Studio, and the second one was with Avant. Now let's check this out. I just want to show you this Azure Sphere kit. So yep. Yes. So this is the MT3620, which is the one I have right now. In Ghana, I am not sure, but if you want it, get in touch with me. I can arrange some for you to be delivered. I can get you some, so just get in touch and I can get some for you. So Christian, I can organize some for you. So in case you need it, I can do that for you. All right. So just get in touch. Now, the other one which I mentioned is in conjunction with Avent, and surprise, my kit just came in. Hold on. Let me show you my kit. Just a sec. So you will be first to see it. I actually took the box apart, but I actually haven't taken it out of the the protective anti-static thing yet. So I'm going to do this right now. First, let me make sure I get all the static things off my hand so I don't burn it or mess it up. And take a look at this. Isn't she pretty? Isn't she beautiful? So don't mind me. I'm so in love with gadgets, especially with things that allow me to connect the physical world to the technical or the software world. So let me push this here so you can see the two side by side. Now, you'd also realize that this also has some headers. Now, with this header as well, I can also get Groove kits for it. So Groove has also shields for this particular version. I've ordered mine. I've ordered my kits, the Groove shield and the sensors. And the good thing is that most of these sensors will work with most of the shield. So I don't need to buy specific sensors for this kit and this kit. Once I have a range of Groove sensors, all I need is a shield to be able to use it on all the other microcontroller units. So that is what we're going to work with. Now, to also work with the Azure Sphere, you need to understand the graphical layout. You need to know what pane is, mapping to what pane maps to what, and you need to understand the difference. So to do that, I'm going to pull up the reference architecture for the Azure Sphere so that we can actually see the various parts of it. So Azure Sphere, let's check out the diagram for Azure Sphere. Uh, pa, 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 pam. Yep, this is the hardware. So this is for Avent. Yeah, so let me just flip this so you can see. So this is the kit that just came in that I showed you right now. This is the one from Avent. So that's the same MT3620, but this is from Avent. So that's what I just showed you. And the other one is what we have for the other one was what we have for Seed Studio. So what I was looking for was the diagram for that. Let me just quickly push this out because I want to show you how the various GPIO pings, because that's what we're going to use to do that. A co-speaker with you at Microsoft user group, so I'll get in touch. Awesome, Christian. Awesome. Sure. Let's do this. Yes, I can actually sort that out with you. So Christian, yeah, just get in touch. We can arrange for that. Okay, so right now what I'm trying to do is I'm going to pull up the reference diagram so we can see the various pin layouts because we're going to be working with that. So we need that we need that to work with, and then we can get into it. It's just asking me to sign in. This crazy stuff. I'm trying to get in there, so let's see which of mine. Let's see. No, let me just use this. And then that would, okay, so let's see how this goes. Just going all the way. I mean, I'm going to docs. I'm looking for something specific. Let's go to Azure. I'm just going to go here and just do Azure Sphere. And okay. And let's see. Yeah, so there's a lot. Let's see. IoT, spatial. Yep. Let's just look for. Let's just do the documentation and we can. So let's do IoT, which can be under product. So if we do Internet of Things, we can go all the way. Boop, 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 boop. Yep, Azure Sphere right here. And then let's look at the, yep, detailed guide here. And let's see the reference device. Yep, overview, guided modules, manufacturer guide. Let's look at the references. Okay, let's see. Yep, yep, yep. So this is what I was looking for. So if you look closely, let me actually zoom this in. You can see the various mappings of the pin, all right, of the pins on the Azure Sphere. So telling you the pin number ground, pin 1 is ground, all right, pin 2, I think that's volt, okay, all the way. So you can see GPIO pings, you can see all the pins labeled, here. So that the reason why I'm showing this is so that you actually understand the various pins on the board and how they are connected. So let's look at the reference design. I can show you can actually see this in a much more uh, colorful way that gives you a better understanding. Yep, there you go. Yep, so let's use this one. Yep, because this is what we're using in today's show, so it will just be much, it will make a lot more sense if I'm showing this one. So we can see how it maps. Let's see if I can just stand this out here. So we can see the headers, GPIOs, and the layouts, which GPIO correspond to which pin on the board. Once you understand the layout, you're fine. Now, the next thing is that to be able to use or access the GPIO pings on the sphere, you need to use the GPIO library, all right, which has been provided thankfully by the community in collaboration with Microsoft. You can also contribute your own GPIO library. Now, this is it's a C file, so if you have any specific sensor or hardware, you can contribute that to the code base. So now, what we want to do today, we want to technically know how can we actually interact with these sensors through the shield in our application. So let's just get right into that. I'm going to minimize this. Let me bring this here, and then let's see how this is going to work. So let's start off with the temperature and humidity sensor. All right, so let's see, temperature and humidity sensor. So yeah, so this one, hopefully you can see this properly. Yeah, it's not autofocus, so it's um, let me get this a bit here for you to see this. Yeah, temperature and humidity sensor, right? So that's what we're going to use. So let me for now, let me just take out all the other sensors. Let's just put them on. Let me move this here for now. We'll come back to this. So this sensor um, technically just reads temperature and humidity, and then report it. It's currently on I squared C, and just report it to the application. So we can have this respond to setting reactions based on the change in temperature in our room. We can define different application or use cases for this. So I mentioned that we're going to use Visual Studio. So let me fire Visual Studio, and you can actually add once the process is the same. Once you connect to one sensor through the groove sheet, you realize that it's just the same process. You just have to add stuff to it and build upon that. So we're going to start with this, and then for those that don't have the kit, I think there's a simulator I'll find and share with you. Else, just get in touch with me. I can arrange for you to get your own kit. So let's just go ahead and set up our environment. And you remember that I mentioned to make use, okay, to make use of the how do you call it? To make use of your sphere, you need to claim it. We've gone through that process in previous videos. So if you want to do that, if you missed it, just go check that out. So let's just get straight into some work. Let's get this here. Okay, so I'm going to open my Visual Studio. And I always like to run it as an administrator. And yeah, I'll keep this here for now. And we are going to make use of the Groove Shield library. All right. And this is actually a fork from the Seed Studio library, which is compatible with Azure Sphere. All right. So hopefully everything should work well and we should have some fun. So I'm going to go ahead and do this. First of all, let's go check out. Let's go check this out so we all know what we are working with. As I mentioned on my stream, I like to be very, very interactive. I don't want to do polished. I don't want to do polished stuff for you guys. So um, where is that? Let me copy. Let me get this link and then we can check this out. Okay, so this is the GitHub repo for the MT360 Groove Shield. So if you need to take a look at it, I'm putting it right here for you. So what this does is it has access to all the, it gives you access to all the, the libraries for the various sensors, and then enables the capabilities that you need to work with. And you can see the header files for the groove relay. So these are the, so for instance, if you wanted to use any of the sensors that I showed, you would need all these header files. So if you included the groove relay, which I will use for the next thing to connect with the relay, I'll need this header and include it in my project. Now, because that is I squared C, we're going to be using the temperature and humidity like I mentioned. I think it's SHT31. Are we sure about that? Yep, 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 yep. We're cool. We're sure about that. So that's what we're going to use. So to make this easy for us to start making use of the shield, I'm going to go ahead and clone. Let's copy this. I'll clone this, in an environment so that we can make use of this. Okay, let's do this. Okay, hopefully this is big enough. I think I did something. Let's check this. I think it was the sphere. Let's see. Yeah, AZ sphere. Yep. Azure sphere. Oh, okay, so I have this in a Git. So, let me just create a different one. I'll just say AZ census. Okay, so let's use that. Let's create let's create that and cd. Okay, so we're good. So now I can say git clone. Let's clone this into this repository so that we can have access to the file. So we can have access to the project. All right. So let's see what we have in there. Yep. So we have the library. All right. We have the library in there. And so we have the library in here. All right. And I think there's actually even a solution we can open. So let's go ahead. Let's go ahead and open that and just make some modifications to it. So let's go down here. Let's go to our Visual Studio. Let's actually open a local. No, let's just say open a project or solution. And I think we put it here in a repo. And then AG sensor. So there's a solution here. So yep, there's a project here as well. Hold on, let's see. This is a Visual Studio solution. We don't want this. We want to put this right here. So the challenge would be um, we could open this project and modify it, or just create our own. Let's see. Let's check this out. Okay, I'm going to open this project and just let's just assess the project. Really? Hmm. I, I think I just have to probably updates project loaded and ready to use. Okay. So let me go full screen so you can see this. Get this out of the way. Um, let's see if I can get my zoom it to work. Yeah, so zoom it is a tool that I use to, like things like this. I can use it to, zooming and give you some. Okay, so references, external sensors up. There you go. The groove shield is here. Is right here. The groove shield is right here. Awesome. So let's open this. Oh, so this is all the relays. So as you can see, all the relays have, all sorry, all the all the headers for the various sensors are here. All right, just because we can import them. So let's do that. Let's do that. So let's go back and check this out. Let's see the common, the delay. So external dependencies. Okay, that's cool. It has all the files there. Okay, yeah. So we're just perusing, just checking out what was in the solution. So let's go ahead and create our own solution now. So I just click on create, and I can do Azure Sphere. I can just type sphere, and when I type the sphere, you can see that there is it tells me there's a sphere, Azure Sphere Blink, project. Um, we can just use that template and modify it because that gives us the base stuff. So here I'll just call this uh, I'll just call this sensor. Let's call this AZ sensor. Okay, and here I'll make sure repos. I'll make sure that I'm actually putting it in that folder where in this folder. Yeah, I'll just make sure I'm putting it here. That's just because this gives me access. All right. Um, it gives me access to the links of the libraries and the headers so I can make use of them. That's why I'm doing that. All right, so yeah, I'll select this so I know it is there. Uh, okay, and then create. All right, so here you realize that when you have also options here, to just click this to do further things. I want to create a CMake file, I want to target another platform. I can do this by just clicking the links shown here. All right, so let's open this up. Let's see, how do I view? We can go full screen, but let me go back and use my zoom it so you can actually see the folder structure. So we have the folder for the file, and then we have the manifest, the versions, the CMake list, the settings, and the launch, and then the main CS file. That's the entry point of the application. All right. So let's just go ahead and check. Now, what we need to do is that we need to go to the CMake list to define the processes, the build process for application. I mean, we don't need to do this most times, but it's just so we know what libraries we're using and all that. So I'm going to open this up. All right. We open this up, and then we can see, let's do this. So we realize that, yeah, as a sphere image file, the project name, pretty much this is fine. All right. This is fine. This file here just defines the build process and the locations for the libraries and all that. So what we are going to do is that we need to add the reference. Okay, let's add the reference to the Groove Shield library because we are going to use the shield, so we need to make the reference to that. Okay, so I'm mentioning that because we're going to use the shield, we need to reference the header files for the library so we can use that in the application. All right, so let's just go over that. Yep, so you can see this. Let me just zoom this up just to make it a lot clearer for you to see. Okay, so yeah, yeah, so let's see the project. Where's the project? So the project is here. Can I just add it under it? Just add a subdirectory to it as the output. So I think I'll add that here. So what are we adding? We are adding a sub. We're adding a subdirectory. Okay, that's how you add a reference. You add a reference to the header files you're using. And this, let's do this. And let's see if it's going to see this for me. So we know this. So in here, if we go back one level, hold on, let me open my file. Oh no, not putting a breakpoint here. So we know that we went into repo. So repo, and then we went into AG sensors, and then we went to that folder. So we know that this is the top level folder. Just here, let me bring this here so you can see this and actually understand this. So you realize that it is in this folder, okay, that sorry, it's in the folder that we created the AZ sensor. All right, so it's, if we go back here, that is the whole relative path to the libraries in here. Okay, so let me bring this out here so I can see this in type. So that will be MT 3620, and then it's a groove underscore the shield underscore the library. Yep. And with this is the folder. All right. So if we open this up, right? If we open this up, we can have yeah, we have all the group, we have all the headers. Yeah, so we're good. So we're good, we're good, we're good, we're good. So this now will be termed as an out. All right, so yep, there we go. So that is sorted. So this is equivalent to adding a reference. Okay, this is like equivalent to adding a reference to your regular .NET or whatever application you are building. Let me save this. Will we refresh? Yeah. That's fine. I don't really mind about that. And then once that is done, okay, we need to now set the application, how do you call it, capabilities. But before we do that, you realize that we've added an executable here. That's a project name. And then down here, target link libraries. Okay, so the project name, the app, we do all that. And then we now need to add the new headers that we've added. So we're using the word empty. I can actually just copy this whole thing. All right. I can copy this whole thing and put here. Yeah, that is because that will be found here. This is it. All right. It will be found in this folder here. We would have that file, header file shown here. So let's see. Yep, in here and groove empty show. Yeah, so we'll pick it from all these files. Okay, so that is it by adding the reference. That's all we're going to do. I'm just saving this so that we can see this file. Well, let me get this out of the way so you can see a full screen. Awesome. Now, the next thing we need to do now is to set application capabilities. Now, one thing I mentioned is that the reason why, the reason why Azure Sphere is one of the secured MCUs is that you define the capabilities of your application, which means that you determine what GPIO pings your application has access to. So this prevents, this makes the attack surface, smaller. So if you define an application and the GPIO pings they have access to, if there's a breach, it's just to those resources. It can't move to other resources. So this is one of the cool things in terms of securing your application using Azure Sphere. So that's one of the reasons why I like that. So let's go ahead and add that. Now it also follows the principles of least privilege. So we're just defining the minimum use case for it. All right. Um, we can go ahead. I can and this is coming. Let me bring this back here so you see. Just like I was showing, I mentioned to you that you can see the reference. Okay, you can see the reference files from here. All right, awesome. Okay, so let's get into it. So we have our reference that we can use right now. We need to define our capabilities. So to do that, I'm going to close this and I'm going to open the the app manifest. Sorry. I'm going to open the app manifest. So now the app manifest is where you define the capabilities to say that, well, GPIO whatever is pin 1, pin 2, pin 3. That is what my application has access to. Or you want to say that my application has access to the I squared C or UART or whatever pin it is that your application has access to. Okay, so let's go ahead and add the UART, IUS to it. So we open this and I'm going to tell it that I want to use the UART. Let's look closely. I think that's what it's using. Okay, so we do this here and then I'll say UART. Yep, I'm adding that. And what am I adding? I am adding the ISU 0. Yep, let's clean it up a bit, make it a bit beautiful. Save this. And yeah, practically that will be it for here. Now, the reason why we're adding that is that to access the I squared C, let me take you to the bench. So I show this here. Now, if you look closely, okay, if you look closely, you realize that I hope this actually can be shown. No, where is that? Yeah, it is here. Let me actually turn this way. Yeah. Now, if you look closely, you realize that the shield is connected to the I squared C pins. All right, it's connected to the I squared C here, right here. So the whole idea is that to be able to access that, you need to bring in the ISU, okay, and that is where it uses UART and then the I squared C to access, the sensor. So that's why we are adding this to our capabilities list. All right. And the thing too is that the temperature and humidity sensor, okay, we can only access it through the built-in that built-in UART port through the I squared C. And before then, Azure didn't support I squared C. All right, the Azure Sphere didn't support I squared C, so they had to go through like the UART. It's kind of like a workaround. That's why they are using it. It's kind of like you're proxying it through the UART. I think till now, the Azure Sphere doesn't directly support the I squared C. So even though you put it on I squared C, we're just proxying it through the UART. All right. So, and then we're also using GPIO 9 for control, right? So we have GPIO 9 also for control. So technically, um, that's it. And if we go back to the reference, you'll be asking what is GPIO 9? Okay, let's check the reference. If we go back to the reference, where is that? Let's go. Where is that? Okay, so if you look at GPIO 99999, uh, where is that? 9. Let's look at our 9. Let's go GPIO 9. No, I've opened a much technical document. Let's see if this. Yep, there you go. Good. So look at this. GPIO pin what 9 right here. Let me actually zoom in so you see this. So GPIO pin 9 is actually an LED. It's the green LED. All right, green LED. Green LED. So putting GPIO 9 here just simply means that we are accessing the green LED on board. All right, so we've defined our capabilities. Now let's just go ahead and add some code that allows us to read the data. Okay, let me put this full screen for you. Okay, so let's go ahead and open our main file, which is where all the magic is going to happen. Where all the magic is going to happen. So we need to add a few headers. So standard boolean is there, time is there, string, the standard library. So I have arrow time, string, the boolean. Let me add the standard library. I can get the standard library in there. I can get the signal header. Signal here. The library, the arrow. Okay. Let's just make sure I have all that. Signal, boolean, my standard library. my string and time. I do I have some OCD for getting things in the way that I want it. So my error 1 2 3 4 5 1 2 3 4 5 6 my error files, and then let me go ahead and add. Let me go ahead and add the groove temperature and humidity sensor. Okay, so what do? We include, and then if you remember, because we had it listed as a reference, you can see we have the out. No, we're not using that one. So let me do this. The empty. Yep. Let's see. Empty groove shield. AG sensor. Blah blah blah. Okay, so we'll just go back one bit. So you know what? Let me do this. This should make our life easier. I have some code sheet. Okay. Just to explain, we're calling the groove, and then sensor, groove humidity. Because if you remember, if I open the file again, take a close look at this. This is the folder, and you can see groove.h. We've called it here. And then we went into what sensors, and then I called the groove temp hum s31. Where's that groove? Yep, there you go. This file here. Okay. So we have that also here. Let's see. Groove temp. Yeah, right here. There you go. So we have it here. So you know that I'm not making up any things going on. Okay. So before we need to do some instantiation before we go into the main method. All right. So let's do static volatile. It's a sig atomic T of type, and let's call this termination request, so that we can use this to tell it when we want to terminate it. Okay. Then I'm going to create a little function. So static void termination handler. Hope I spelled that correct. And this will take an integer of signal number, just to let me know. Okay, and this is just we're just gonna just change the termination state. All right, so I'll just say termination request here is true. All right. Yep. So that's it. So this is just going to handle when we signal we want to stop reading. All right. That's what it's going to read out. And then we have our main. All right. Right. And this is where the magic is going to happen. So I'm going to I'm going to modify the main. The main will take an integer of we have an argument, and then we'll have a car of arg v. So yeah, so we have an arg3, an integer of arg, and then a car voltage. And I mean, just for the sake, let me just get rid of all this boilerplate code that has been generated. Because remember, we used the blink sample, so that's why it's quite lengthy. All I want to do here now, let's get rid of this. All I want to do is say uh, application starting. Yeah, let's break that down. I like to be a bit dramatic, so let's just save that way. Awesome. I don't need any of this. So get rid of let me just get rid of all this. Okay, let me just get rid of it. Save this because we're going to define it. Now we need to register um, a signal term handler for the termination request. Okay, so we know when to terminate. So I'm going to do a struct. Where's that? I'll do a struct and call it sig action of type signal action called action, and then let's do a memory set. And I know this is a bit this C, so if you're doing IoT, this involves a bit of a code. It is not a drag and drop as we saw some time back. So so the action 0 and the size of my struct, and it is of type sig action. Oh, hold on, what just happened? Okay, yeah, so yep, and then let's do let's create a handler that sets and set it to the termination handler we created here. Yes, and then the sig action itself would be a sig term. Yep, be a sig term, and action will be null. Don't worry, I'm going to make the code available, okay, on the GitHub repo that you can actually go check it out. Okay, so now that we've done this, a signal termination request, now let's change the GPIO number and then the number in the app manifest if required. We don't need to change that, but let's just change it to fade, kind of like give us some info. Now, this is a test that you perform in Azure Sphere just to ensure that the correct capabilities pin is being used in your application. So you can't use a pin or a GPIO that is not being defined in the capabilities list. All right. So let's do that. It could be any name, GPIO open as output. And remember we use what? 9. So, and this will be GPIO output. So GPIO underscore. This is an where is that? You should have given me some IntelliSense. Okay. So GPIO output mode. This should have been anyway. Well, so push pull because we can send to it, and then this will be GPIO underscore value. Let's set this to high. Okay, let me make sure I got this. GPIO output mode push and pull, correct. GPIO value high, that's good. So we're just standing that And you know that in IoT, accessing or manipulating sensors is a matter of turning some, GPIO pin on or off or high or low or 1 or 0 if you want to take it that way. And then we check and say if FD is less than 0, it means we don't know which port you're talking about. Okay. And then I have some code I have been reusing. So yeah, check that app manifest includes a number, and then we pass a string output, and then I can return -1. Okay, so let's be sure. So this is done. This is my log. Let me move this here a bit so you can see this. Oh, okay, so this is why, because I was like, there's something wrong here. Okay, so this is why this is happening. I need to do a log debug. Yep, because I am logging. I am logging. Yep, there you go. Yep, hopefully this is good. Log string, there you go. Return. Yep, we're good. Okay, as if this is not enough. Now, this is the time to initialize, okay, our groove shield and temperature sensor. So let me just do this. Initialize um, groove shield and sensors. Okay, so we do this int. This is I squared what? C FD, and then we'll say my groove shield. Let's see this. Initialize. I'm initializing what? The I squared C FD. Alright, and setting the baud rate 1152 Okay, let's do this, and then we can say SHT31. This is our humidity and temperature sensor. Let's say this is our groove temp. Remember, this is coming from here. Okay, it's coming from here. So I'll say this is my groove temp hum 31. Let's go open. Okay, and we are opening it on our what? I squared C FD. Awesome. Okay, now that we have our the groove shield and everything set up. Okay, we have that set up. All we need to do now is go and create some pulses so we can get data. All right. So my structure, my struct time spec. Ba, ba, ba. And we'll call this sleep time. And this will just be for sec. And then now while not terminate requests, as you can see, we define this here. Okay, so until it is true, we don't stop the action. All right, so while not terminate request, what do? So we read, right? Let's copy this. We read data from uh, here. SHT, where is that? Yep, from our sensor here. So we start to read the data from it, okay? And then let's go ahead and create a float for the temperature, which is equal to our groove temperature underscore get. I have let me use my cheat sheet here, and then I'll do the same thing for the humidity. Okay, so my temperature gets this, my humidity get this, and we can go ahead and log this so we see this in the app. So another thing we can do will be to take this information and send it to somewhere like IoT Hubs or IoT Central. Okay, so just have that in mind. So, yep, with that said, we need to now, probably turn on the light for a while. So let's pull it down. So GPIO set value FD, which is our light, our LED 9, set it to low, sleep for a while, and then, we set it back again. So we're just alternating the light whilst we are reading the, how do you call it? We're reading the temperature from the sensor. Now, let me take you back to the bench. Now, if you look closely, you realize that we already have an application running, which is basically to blink, which is basically just to blink on and off. Okay, where's my sensor? My sensor is here. My sensor is right here. Okay, so let's keep this here. How would I be able to blow heat on this? Okay, so I have a heat gun that I can use to simulate that so you see. Okay, so uh yep, so device is working. Our device is connected. Now remember that we mentioned that before I can actually enable or change the device for it to work, um, for it to be in the debug state, because one of the secure things is that when you're debugging and want to deploy an application to your sphere, you need to put it into the development phase. When you put it in the development phase, what happens is that it stops it from receiving any update from the Azure Sphere security services. All right. So how do we do that? Let's go here. If you remember, oh no, I already have one open. I don't need to open another one. No, I can't use this. Let's go ahead and open the sphere command prompt. Okay, and if you remember, we need to do Azure Sphere login, and it will ask me to, I need to log in into my tenant for the Azure Sphere, so I'm going to do that. For some reason, it feels a bit slow today, but I don't know how that is. Well, hmm. Well, so whilst that's happening, again, I mentioned that if you need any of the IoT kits, IoT devices, IoT sensors right here in Ghana, or even probably even if you're in Nigeria and you're watching and you need IoT kits, just get in touch after the show. I can arrange for that to happen and you can get your own kit. So just keep it locked there. And whilst I'm waiting for this to also load, if you haven't heard, if you're in Ghana and you've heard or know about the Microsoft Power Platform, Power Apps, Power BI, Power Automate, Power Virtual Agent, Common Data Services, and you have some interest there. Well, the official meetup is Accra Power Platform user group. Join us. We have our mating meetup coming up pretty soon, and then we're hosting the West Africa Power Platform tour. So if you've not joined the group, you're missing out. Okay, so let's see what is happening. What do we have here? And where is my login? This is strange. You know what? Let me do this again. Even used in the previous. Yeah, let's try the logging again. Let's see if this works this time. Unless of course it's the service that's preventing it. Yep, there you go. So I use this account to claim it. Yeah, sometimes you just have to refresh it and, you know, for your problems, some way, somewhat run away. But today I think there's something going on because ideally this doesn't take a longer time for me. I don't know if it's because I'm streaming or not, but this usually doesn't happen to me. But there's always a first time. So let's see.